Okay, so you sent over this article
Mm-hmm.
about big unsolved math problems.
Yeah.
You know, the kind that make mathematicians, like, really
Totally.
wonder if they need more coffee.
And what's really cool is this angle they have about AI.
Right.
And maybe being the key to actually cracking these
Yeah.
things.
I gotta say, at first glance, I was like, unsolved math problems?
Yeah.
Sounds pretty niche even for us.
It does sound a bit like,
Yeah.
what do mathematicians do on a slow Tuesday?
Exactly.
Yeah.
But the article makes this really compelling point
Yeah.
that
Yeah.
these problems aren't just about numbers in some theoretical world,
Yeah.
you know?
Yeah.
They're like deeply connected to our lives in ways we don't even realize.
Totally. It's like how Einstein's theory of relativity probably seemed really abstract.
Oh, totally.
Way back when, but
Yeah.
now it's how we have GPS,
That's true.
you know?
I never thought of it that way.
Yeah.
So they're like these levers.
Right.
And if we can just figure out
Right.
how to like pull them,
Oh,
who knows what we could do?
absolutely. And one of the most fascinating, I think, illustrations the article uses is this thing called P versus NP.
Okay, I'm going to be honest. I'm not a mathematician.
Sure.
So break this down for me. Like,
Oh, wait.
what is this and why should I care?
So imagine you're trying to plan
Okay.
like the absolute quickest road trip
Mm-hmm.
to hit all your favorite spots.
Okay.
Like figuring out that optimal route.
Yeah.
That's what we call an NP problem.
Okay.
It might take you like ages
Mm-hmm.
to calculate every possibility.
I see.
Okay. Now, let's say your friend says, hey,
Yeah.
I found the very fastest way.
Right.
And they give you the directions
Right.
to check if they're right. You just follow the directions and see how long it takes.
Right.
That's a P problem.
Okay.
It's usually much quicker to verify
Yeah.
than to find it in the first place.
Okay. So P versus NP is basically saying
Yeah.
if it's easy to check if the answer is right,
Exactly.
does that mean it was easy to find the answer?
Exactly.
Okay.
And that like tiny little question
Yeah.
has huge implications.
Wow.
Because if we could prove that P equals NP,
Right.
it would mean there's this like
Yeah.
shortcut to finding all these optimal solutions.
Yeah. So are we talking like,
For all sorts of problems. Everything.
like curing diseases faster?
yeah.
Like optimizing traffic?
Yeah.
Like
Impossible Sudoku puzzle.
maybe even Sudoku puzzle. I don't know.
Right.
But,
Yeah.
it would be revolutionary.
Wow.
But on the flip side, if we prove
Right.
definitively that P is not the same as NP,
Yeah.
that also gives us information
Okay. How so?
because it would mean there are limits
Okay.
to what computers can actually solve efficiently,
Right.
no matter how powerful they get.
So it's like knowing the boundaries of the map.
Exactly.
Right.
Exactly.
Even hitting those boundaries pushes us forward.
Sometimes understanding what we can't do
Yeah.
is just as valuable as knowing what we can do.
That's a good point.
It helps us refocus our efforts
Yeah.
and really redefine what's achievable.
Wow. My mind is already blown. And we're just getting started.
I know.
So we've got this puzzle about problem solving,
Mm-hmm.
but the article also talks about these other
Yes.
math mysteries that are a little more
Absolutely.
grounded in reality.
Yeah, and that's where things get even more, I
Right.
think, mind-bending,
Okay.
because it's things we experience every day,
Right.
starting with something called the Collatz conjecture.
Okay, the Collatz conjecture.
Yeah.
This one sounded like a math magic trick
It really does.
from the article. So,
Yeah.
like, what is it?
It's like deceptively simple.
Okay.
You pick any whole number,
Okay.
like let's say 10.
Oh,
If it's even, you divide it by 2.
okay.
So 10 becomes 5.
Mm-hmm.
If it's odd, you multiply by 3 and add 1.
Okay.
So 5 becomes 16.
Okay.
And you just keep doing that. And the thing is, no matter what number you start with, you always seem to end up at 1.
Any number.
And that's the thing, right?
That's wild.
Like, we can test it with a bunch of numbers.
right.
Mathematicians haven't been able to prove why it works for every single number.
So it's like this deceptively simple pattern,
Yes.
but massive implications, potentially.
Huge, huge.
Okay.
And
The article mentioned chaos theories, so how does that play into this?
that's the really cool part, right?
Okay.
Chaos theory is all about how these tiny little changes
Right.
can have these huge unpredictable effects,
Right.
like the butterfly effect. A butterfly flaps its wings in Brazil,
Yeah.
and it causes a hurricane in Florida.
Right.
You know,
So is the Collatz conjecture like the butterfly's wing flak?
in a way, yeah.
Okay.
If we could actually understand the why
Right.
behind this conjecture, like why it always goes back to 1,
Right.
it might give us a whole new way to look at
Yeah.
other chaotic systems.
Okay.
like weather patterns or traffic flow.
So, like, by cracking this one little rule,
It's possible.
we could have more control over things that feel totally random right now.
Exactly. And it's not even just about predicting the chaos. It's
Yeah.
about understanding the patterns underneath it all.
Right.
Like, imagine making algorithms that can actually adapt
Oh, wow.
and respond to change,
Yeah.
all because we figure out this one
Yeah.
seemingly basic math problem.
Okay, that's mind-blowing.
Right.
Speaking of things that sound kind of simple, but have huge implications,
Yeah.
these Navier-Stokes
Yeah.
equations, which sound way more intimidating.
They sound very complicated.
Yes.
But they describe something that's so familiar, which is how fluids move,
Right,
which is like everything.
right. The air, the water.
The air, we breathe the water,
Yeah.
in our pipes.
Right?
And these equations are already essential
Yeah.
for things like weather forecasting,
Okay.
airplane design,
Wow.
even understanding blood flow in our bodies.
So these are equations that are already hard at work.
Very much so.
So what's the unsolved part?
The challenge is proving mathematically
Okay.
that these equations always hold true,
Okay.
that they always have
Yeah.
what we call smooth solutions.
Smooth solutions. Okay.
Basically, a smooth solution means that the fluid's behavior,
Right.
as predicted by the equations,
Yeah.
is continuous.
Oh, it doesn't just suddenly jump from one point to another.
So like water flowing through a pipe.
Exactly.
It doesn't just teleport.
It doesn't just disappear.
It flows.
It's a continuous flow.
Right.
Yeah.
Okay, so what would it mean if we could definitively prove
Yeah.
these smooth solutions always exist?
Oh, it would be huge.
Yeah.
Imagine climate models that could predict hurricanes with perfect accuracy.
Right.
We could design airplanes and ships
Yeah.
that are way more efficient,
Wow.
reduce fuel consumption and emissions. We could
Wow.
even understand things like blood clots.
Right.
So much better.
Wow. So these aren't just
Yeah.
theoretical math puzzles. These are like
These are like
keys to some of the biggest
Oh,
challenges
wow.
we face.
huge implications.
But this all sounds so complex. Like, how can we even begin to like
Right.
wrap our heads around these problems?
Well, and that's where the AI comes in, right?
Right.
Because we're not just limited to human brains anymore. We've got these incredibly powerful AI systems
Right.
that can analyze information in ways
Yeah.
that we could only dream of.
It's like having this like team of superpowered interns, basically,
Totally.
who can just like crunch numbers and spot patterns like 24/7.
And the cool thing is the article highlights how it's already happening.
Right.
There are AI systems out there that are already
Oh.
helping mathematicians prove theorems.
So they're not even just tools at this point. They're like,
It's like having a research partner who never sleeps.
right.
And what's really fascinating too is
Yeah.
AI doesn't come with the same like baggage.
Oh, that's true.
As humans,
Yeah.
it doesn't have preconceived notions
Totally.
or biases.
It's not jaded.
It can look at a problem totally fresh
Right.
and explore like trillions of possibilities
Uh.
without getting tired or discouraged.
It's like the ultimate research assistant.
It's like having a team member who
Right.
will entertain any idea,
Right.
no matter how crazy it seems.
And speaking of like AI doing amazing things,
Yeah.
remember that whole thing with AlphaFold?
Oh, yeah.
Like-
From DeepMind.
Yeah.
Yeah.
That was huge.
Huge.
Like they solved this
They solved a problem
decades-old problem.
that had stumped scientists for so long.
So it makes you think, if AI can do that in biology,
Yeah, totally.
why not math?
What are the limits, right?
Yeah. What are the limits here?
Like, we're already seeing it
Yeah.
starting to make these inroads.
It's pretty wild.
It is wild.
We're talking about these problems that have stumped
I know.
the smartest people
For centuries.
for so long. And now it's like,
And now we have this whole new approach.
yeah, this new set of tools, this new,
New collaborator.
yeah.
It's an exciting time to be in this space.
So it's not even just about like
Totally.
the math itself.
Yeah.
It's about what these breakthroughs could mean.
What it means for the rest of us.
Yeah, for like the average person.
Because whether it's understanding climate change better
Right.
or coming up with new medical treatments,
Or just making our technology work better.
making things faster, more efficient,
Yeah,
these math mysteries
Yes.
have a real impact
they really do.
on all of us.
Yeah.
And who knows, right?
Yeah.
Maybe one day it won't be a human mathematician
Okay.
who wins the Fields Medal.
Wait, you're saying an AI could win the Fields Medal?
It's like the Nobel Prize of Math.
I know. That would be wild.
It might sound far-fetched,
Yeah,
but so did self-driving cars
Totally.
not that long ago.
that's true.
You know?
Yeah.
So the pace of progress is
That's
just,
incredible.
it's mind-blowing.
Yeah, and I think even more than that,
Yeah.
It's not even about the awards or whatever.
It's about the journey. Right.
It's about figuring it out.
It's the thrill of discovery.
Yeah.
And unlocking this new knowledge.
It really is.
And that's
what's so exciting.
It's so cool.
Is that this is just the beginning.
You were just at the very beginning.
And who knows what's going to happen.
Who knows what we'll find.
What we'll discover.
Yeah, it's an incredible time to be curious.
And maybe you'll be one of our listeners.
You never know.
Who makes that next big breakthrough.
You never know.
So thanks for joining us, everyone.
Thanks for listening.
On this deep dive.
Until next time.
Keep those minds open and keep diving deep.
Absolutely.